Welcome back to my channel. I'm Brian Kafke, and we are continuing in this video the deep dive question and answer interview with expert Daniel Zafar, who works for Databricks solving customers' biggest problems. This is interview number 3, and specifically what we'll be talking about include Python programming and things you need to know. Is Scala programming needed anymore? Open source projects available on Apache Spark, which means you can use them in Databricks. The machine learning model training ecosystem using R on Spark. Common programming mistakes that Daniel sees in his work. And do we need resilient distributed data sets, RDDs, anymore? So let's jump in. So changing gears a little bit now, focusing more on programming on Spark. So we talked a bit, and I think we may have covered this a bit, but so Python and Spark is extremely popular, but I still see a lot of people out there, especially people who've been doing Spark for a long time. They got to know Scala, and that's the language you got to learn. And I'm actually been coming back and saying, actually, no, I think that the necessity for using RDDs is seriously deprecated. And I can't see a reason why Python really can't be your go-to language. But do you see a place where you say, well, this is a case where you really need to go to Scala or Scala, whichever you pronounce it.
Yeah, completely. I would say for 95% of the use cases, you should just use Python. You should use PySpark because if you already know Python, most people know Python, not many people know Scala. Why spend the extra time, right? And like I said, with Pandas UDFs, you can get stuff working way faster than you could in Scala, depending on what you're doing. Plus, you have all this math and all these models that are in PySpark. Like it's absolutely required. That being said, we do have some very advanced customers that want to build out their own functionality within Spark. So for instance, maybe they have an API that has some sort of data source in it, and they want to create their own data source to read in the file. So they would do a spark.read. And then their own data source. They wanted to build that out. Obviously, you have to know Scala.
Okay. So there you were actually building functionality almost into Spark. And since it's running on the JVM and it's written in Scala, that's where Scala would make sense.
Exactly. Or for instance, if your code base is already in Scala, then of course, use Scala. It's you have access to the DataSet API, which allows you to do a lot better type enforcing. So
yeah, I've seen a lot on that. It's funny. It looks like the DataSet API intuitively seems like it should perform much better, but I don't see it promoted much. And it seems like the default in Scala is actually to use the data frame first, and then you can go to the data set if you want. Is that accurate? Or
yeah, I mean, so the DataSet API is only something that's supported in Scala because Scala is very strictly typed, right? And Python isn't as strictly typed. And so in terms of performance, I think that they should be the same. It's just that when you're developing an application and you really need that strict typing, like you really need to know what each column is going to be and so on and so forth. Like, you need that strict typing in your data frame. That's when you want to use the DataSet API.
Did the data set also take less space because it knows it's 3 characters, it's 5 characters, it's not storing like all that extra information?
That's a great question. I'm not sure about that one. It's certainly possible.
Okay, that's always been my issue with Python being dynamically typed. It has a lot of overhead to doing that. That's why like NumPy is so efficient. But
yeah.
So this should be easy. But what are your thoughts about Apache Arrow?
Yeah, Apache Arrow is super great. Big fan of the project. Dremio, super cool company that sort of worked on a lot on Apache Arrow. I believe we'll have some news coming up related to Dremio. I don't know what it is yet, but I've heard we have news that's happening at Spark Summit this year related to that.
As we talk about these, it occurs to me too that one of the key differences between something like Snowflake versus Spark and Databricks is the fact that one's open source. While Databricks has a UI, which is proprietary, 90%, I guess, of everything under the covers is really Spark, and that's open source. So all these projects Databricks doesn't have to build everything. People bring things to it for free. And I think that's a big plus for, like you were talking, like whether it's the Arrow or all these different projects that enhance it, it's kind of supported by the open source community, which is a nice addition.
Yeah, definitely. In terms of Spark, I think we make over 50% of the commits to Spark. So it's a considerable, we definitely have a lot of say on where it's going, but we're definitely not dictators on it. And then a lot of the software engineers that work at Databricks, most of them are working on we have a cloud platform we're trying to run here, and we need it to be infinitely scalable. And we need to automate literally everything about the cloud environment. So, yeah.
Mm-hmm. All right, so that actually, I don't think that I think I know the answer, but are there any glaring problem areas in PySpark despite Apache Arrow? And I'm hearing no. So if there's really nothing that you'd say, well, there's this one problem area you got to watch out for.
In my opinion, I think it could be simpler for people to learn. Mm-hmm. Because it is so powerful. It's going to take you just some time. It's going to take you a few hours to code up your first UDF. I feel like, it might not take that long, but I wish it was a little bit more intuitive. Some of the aspects of PySpark, most of it's perfect. It's just, some of the stuff can be a little bit, yeah.
Okay.
That's my only complaint. Yeah, better errors, more intuitive would be awesome.
All right, so Spark supports machine learning integration. As we talked about, as you mentioned, a lot of open source frameworks. I've seen things like H2O, TensorFlow, PyTorch. Are there any of these frameworks though that you like? Because so one of the things when I first was learning Spark was that it's got MLlib built in, and then I see all these extended third-party frameworks. Are there any gotchas? Are there issues with it? Does it actually really scale and integrate well on Spark?
Yeah, absolutely. Yeah, it definitely works very well for like what it is. That being said, there are going to be some additional functionalities that customers might look elsewhere for. Like for instance, if you're fitting a gradient boosted tree, which is super common, right, for data scientists. If you wanted to, let's say, implement your own custom cost function, you can't do that in Spark's ML package. Like you would need to use XGBoost for that, right? So there's some things like that. It's that people use sort of external tools for. But honestly, my take is most people use these external tools because if you've been coding in H2O on a single node for 5 years and then suddenly you want to scale it up, you're not going to switch to a completely new framework. You're just going to use the scalable functionalities that come with H2O, right? Or if you've been doing great with XGBoost or TensorFlow or PySpark, you'll just try to distribute that, instead of moving to a totally new different algorithm. But in terms of sort of PyTorch and TensorFlow or deep learning in general, that's not something that is sort of a part of Spark. Spark has sort of like the other sort of algorithms, like the tree algorithms, regression, classification, stuff like that, the sort of core data science algorithms. For really obscure stuff, you have to get it from, R's libraries or Python, scikit-learn. But then for, deep learning stuff, you would need to use sort of Horvath or Spark trials in HyperOpt to be able to get distributed functionality to some of those deep learning models.
And from what I hear you saying, if I'm getting it right, is that distributed processing for these sort of third-party models that are not part of Spark, it's really up to their support to be able to scale out. And I guess results may vary depending on what they can do.
Yeah, so I would say for non-deep learning stuff, I think our tools fit the bill very nicely on Spark. But for deep learning, it's not something that the Spark's tools sort of address. So what you do is you'll take those and then sort of distribute them, run them at scale using the tools that are on Databricks and Spark.
Okay, perfect. We talked a little about this, but how would you rate the use of R on Spark? Is it, I think it's, you would say it's probably not comparable to Python, but.
Unfortunately not. It's one of those things where there's just not a lot of R users. And so it's been hard for us to prioritize keeping the API at par with Python. And it looks like it's sort of a sort of self-fulfilling prophecy, because as Python gets further and further advanced, more users move to Python, right? And then there's less users in R, so R gets less prioritized. The cycle continues, right? So it's something where, you know, I was an R user just straight before I joined at Databricks, and I would love for the R API to be better.
Yeah, it's a challenge. I can say this. I started more with R first, then moved to Python myself. Are there any planned improvements for Spark R at this point, or is it kind of in a stasis?
Yeah, I mean, it's not deprecated or anything. It'll keep on getting better. I think the main thing for R, and I can't comment on Sparkly R because, you know, Databricks doesn't maintain that. But for Spark R, I think we're just sort of holding the line. We just have to sort of, as all the features come out, update them Spark R, update them on PySpark, and then Spark R is always, I think, going to be maybe a little bit behind PySpark at this point in time.
Okay. I think one thing I like too about R, which you can do, is use the local visualizations like ggplot2 or something, so you can bring things local and then do some plotting, which is kind of nice, even though it won't scale. But
yeah, I mean, on Databricks, all that stuff is sort of built in. You can run plots interactively from just displaying a data frame, so that's nice. But yeah, if you're not using Databricks, then it's going to be a little bit more difficult, I think.
So what would you say? I'm kind of getting now into more performance issues, because I know a lot of people run into these things, and it sounds like you hit them a lot. What do you see as the most common mistakes people make when it comes to doing applications on Spark, doing their data processing?
Right. So I think before Spark 3, I would have said shuffling, like the shuffle partitions, people just not tuning those correctly or tuning them really badly. But since Spark 3 came out, I really haven't had to deal with tuning shuffle partitions much. So these days, I would say people using for loops, you know, and I think that this sort of, it's worth going over this, because when we talk about sort of the data frame API, like what is the data frame API? Because, you know, we're running these commands that are sort of SQL-esque sort of commands, or like, you know, with columns or data frame manipulation. But really, all of it sort of gets fed into the RDD API. The RDD API then, you know, runs it everything. So what the Spark data frame enables is that it generates a query plan, and that query plan can be optimized into the best performing thing possible. So you could write your Spark code like 5 different ways. After it goes through Catalyst and query planning, it's going to end up as the exact same query plan, right? Like you could put your filter like wherever you wanted, and it's going to push down that filter to right before the read, right? So, so I would say like the main performance thing that I see personally is that people try to optimize the Catalyst optimizer. So they'll run like for loops or things like that. They'll try to sort of like batch up their code or something. Versus I think the best bet is, you know, let the Catalyst optimizer that analyzes your query plans and optimizes them, like let that thing do its job. Try to give it a good sized query plan. Don't do a bunch of caches all over the place. Just give it a good sized query plan. And then let it sort of run with that and see what it can do, because it's gonna be smarter than you and me, because it's been set up to do that by itself. And that being said, sometimes if you have like a super huge query plan, Every once in a while, you might hit a Spark bug. It does happen. We get like, I want to say 4 or 5 every month with our team at Databricks. In that case, you can just shorten your query plan a little bit and get it that way.
You control the query plan. Is that a configuration option or something?
It's just by sort of where you cache your data, or like where you persist your data. So like, yeah, it's a super good question. So let's say that, so in Spark, there's transformations and actions, right? So with a transformation, it's just going to add on commands to like the list of commands that need to be run. And then once it hits an action, it's going to run all the above commands, right? So a trick that people do to sort of shorten the query plan is they'll just put an action wherever they want to cut off the query plan. So the most common one is a count, right? Because count it's going to force Databricks, or sorry, it's going to force Spark to sort of run through everything and generate a count. So if you do like your data frame .cache.count, it's going to run everything up to that point. That tool right there is the most useful debugging tool that's in Spark. Like, it's not very well recognized, but that's the tool I use most often, because if you have this huge thing of code and you need to figure out where the issue is, you can just move that .cache.count around, and it will and you can really quickly sort of get to where the issue is.
Interesting. Okay, that makes sense.
It's all lazily evaluated.
You force it to break up the plan into chunks and then speed grids. Okay, nice. Okay. I think I talked about some of this one. Are there any cases where you think the RDDs are still really needed for certain edge cases, or?
Yeah, I mean, if you're not working with a table, then it could be useful for sure. I mean, the RDD API is deprecated, like it's feature complete. Everything runs on the RDD API. We don't usually recommend that people use it, just because if you use RDD API, you don't get the Catalyst optimizer, right? Catalyst optimizer is before the RDD. So, yeah, but if you're not using a table, right? If you're not using a data frame, then
yeah,
that's actually
parsing like a weblog. I know I've done that myself, where you're kind of looking for chunks and breaking it up, then may not then use an RDD.
Yeah, definitely.
But yeah, I mean, it doesn't seem like there's a lot of cases for it anymore.
I would always try to like if you were about to use the RDD API for something, I would say, wait a second, is there a way I can do this with the data frame API?
Yeah,
that's probably what I would do.
Makes sense. Well, I think for me, and a lot of people who come from more relational background too, anything that's more table-like is a lot easier to conceptualize and work with than going through map reduce and everything and stepping through things. So yeah.
Completely.
I want to thank you for watching this segment of the video with Daniel Zafar, a deep dive technical expert software engineer for Databricks. Please continue to the next video where we'll get into more details. Until then, I'm pulling for you. We're all in this together. Thank you.